Hello my friend, welcome back to the TeamMachines channel. Today we're following Matt Williams as he crafts a beautiful brass pen from scratch, using the classic Myford ML7 lathe. This process demands patience, precision, and a steady hand, but the results are absolutely stunning. Matt begins with a solid brass rod, about 12 to 15 millimeters in diameter, securely clamped into the three-jaw chuck of the lathe. He carefully checks to make sure the rod spins true and stable before machining. First up, rough turning. Using a cutting tool, Matt removes the outer layer of material to clean the surface and bring the rod closer to its final size. He works with moderate cutting speed, making light passes to avoid overheating the brass. Once the roughing passes are complete, Matt moves on to shaping the pen body. He turns a gentle taper along the shaft, giving the pen a comfortable, ergonomic feel. He also cuts small shoulders, little step features, to define the sections between the pen tip and the cap. Before drilling, Matt uses a center drill to create a pilot hole. This ensures the main drill bit stays precisely centered as it drills deeper. Now, the main drilling operation. Matt uses a twist drill size to match the refill he plans to install. Since the hole needs to be deep, he drills in short stages, regularly clearing chips and applying cutting oil for smooth drilling. He carefully controls the drilling depth, deep enough to house the refill, but not all the way through the pen body. For parts that require threading, Matt taps internal threads into the drilled holes. He adds cutting oil and turns the tap slowly, backing off every few turns to break chips and protect the tool. When external threads are needed, Matt uses a die and a hand tool, or sometimes special lathe attachments, to cut clean, accurate threads on the pen body. With the machining finished, it's time for surface finishing. First, he uses fine grit sandpaper, around 400 to 600 grit, while spinning the pen slowly on the lathe. This smooths out tool marks and prepares the surface for polishing. He then switches to even finer grits, 800 to 1200, to eliminate any small scratches and give the brass a silky smooth finish. Next comes polishing. Matt uses a buffing wheel combined with a metal polishing compound. By moving the pen carefully against the spinning wheel, he brings the brass to a brilliant mirror shine. After polishing, he wipes the pen clean with a soft cloth and a light solvent to remove any leftover polishing compound or oils. Now, assembly. Matt selects a common ballpoint refill, typically a Parker style, and carefully inserts it into the drilled body. Depending on the design, he installs a retainer or a small spring to hold the refill securely in place. He screws it onto the body using the threads he previously cut, making sure the fit is smooth and snug. Finally, Matt gives the finished pen a thorough inspection. Does the refill operate smoothly? Are the threaded connections tight and precise? Is the overall finish clean, polished, and well proportioned? And of course, he tests the pen by writing a few lines, ensuring it's not just beautiful but fully functional too. From a simple brass rod to a stunning handmade pen, a true showcase of craftsmanship and attention to detail. While crafting a handmade fountain pen on a manual lathe requires great skill and patience, creating more complex parts today calls for a blend of advanced technology and precise programming. A perfect example is the machining of a chess rook using a 5-axis CNC machine. In this project, Andy DeBuck used Fusion 360 to design a detailed 3D model and program all the necessary toolpaths. The machining process was divided into clear stages to fully utilize the power of the 5-axis CNC machine, ensuring high precision, smooth surfaces, and excellent final aesthetics. Profile roughing contour, 3+1 axis. Roughing the overall profile with fixed rotational axis, efficiently removing excess material. Top contour, semi-finish, 3-axis. Semi-finishing the top section to prepare for final passes. Inside pocket, roughing, 3-axis. Roughing the internal cavity with accurate depth control. Castle contour roughing, 3-axis. Roughing the top battlement features, the castle parts. Middle contour semi-finish, 3+1 axis. Semi-finishing the middle body section for better definition. Top 4 finish, 3-axis. Finishing the top surface to a smooth, flat finish. Castle finish, 3-axis. Final detailing of the battlement features with precision toolpaths. Castle chamfers, 3+2 axis. Creating precise chamfers on the battlements using 3+2 axis programming. Middle polygon finish, 3+1 axis. Finishing the polygonal section of the body for clean, crisp edges. Base polygon finish, 3+2 axis. Finishing the base area with multi-axis support for optimal accuracy. Top wall finish, 4+1 axis. Finishing the vertical top walls using simultaneous 4-axis motion and a fixed 5th axis. Middle ball grooves, 3+1 axis. Machining decorative spherical grooves around the middle body. Middle ball grooves ring, 4 axis. Machining a continuous groove ring around the body using 4-axis movement for a smooth, flowing look. Every step was carefully planned and executed, from roughing to finishing, demonstrating deep expertise in 5-axis CNC programming and toolpath optimization.